Okay, here we go. All we're going to do today is a quick review. Now, this is not what we were just finishing up. That was 11.1. That was on rational numbers. We'll pick up on 11.2 from the book tomorrow. Today's just a quick review. I noticed yesterday when we were last couple of days when we did the PSAT review, a couple of you, your eyes were rolling in the back of your head about factoring quadratics. It is literally the next chapter that we do, not the chapter we're in right now, but the very last one that we'll do. So it's a worthwhile quick review. This is not going to be a full 50-minute class. We should get done with this one pretty quick. So you have a worksheet. There's a number of questions, and they all say the same thing, which is factor each completely. Before we get started, I'll just go ahead and do a quick class on generally what it means to factor. When you factor, it is asking you to take the given expression and turn it into multiplication. In other words, product of two things or three things. What does that mean to do? It means to look in each term and figure out, is there something that I can divide out of both things? And what do they have in common? Well, both of these terms that I just circled in red have an M in common. So if we factor out an M, in other words, I'm dividing both terms by an M, we get that familiar parentheses. What times M is M squared? M times M is M squared. In other words, I'm dividing out an M from the first term, and I'm going to divide out an M of the second term. So if I divide an M out of the second term, what times M is 5M? Well, that would be a positive 5. This is really the distributive property in reverse. And so this is the final answer right here, M times the quantity M plus 5. The ones you'll be doing today are two flavors. One is a binomial, that's two terms, and one a trinomial. The next one we'll do will be, I believe, or the one after that will be a trinomial. When you have three terms, a different process. But when you have two terms, this is the process. You look at both terms, first one and the second one, you ask yourself, what do both terms have in common? In this case, both terms have an M in common. You write an M on the outside of the parentheses, you put an open parentheses, and then you ask yourself, what times this is this? Well, what times M is M squared M? You put that as your first term inside the parentheses. And then you do the same thing. What times M is the second term? What times M is 5M? 5. M times 5 is 5M. And that's how you do it. All right, so I'm going to do not all of these, but I will do a selected number of these. And then what I'll do is I'll hang on for as long as you need me to answer questions about this worksheet. If you know what you're doing, obviously you can get started at any point. And this is stuff that we have done before as well. So we just did number one. Let's take a look at number two. Now, number two is flavor number two. Notice we have a trinomial. A trinomial meaning there are three terms. 1, 2, 3. There's three things. Now, trinomials are factored differently. This is your standard. It's going to factor into a series of parentheses. It will always be, if it's factorable, two sets of parentheses. That's your start. And then comes the magic. And the magic is we look at the very last number here, the -2, and we ask ourselves two questions. We ask ourselves, what two numbers multiply, M-U-L-T, multiply, and give you -2, that when you add those two numbers would add to the middle number. You're like, well, there isn't a middle number here. Well, remember, there's a hidden 1 in front of X. So I'm looking for what two numbers multiply that give you a -2, that when you add them together, you get a +1. So how do we figure that out? Well, we just go through all the possibilities. So what times what is -2? Well, there's a couple options. There's 1 times a -2. There's a -1 times a +2, and that's actually all the options. So here are the two numbers multiplied together that multiply to -2. Now, which one of these would add to a +1? If we notice, the top one would add to a -1, and the bottom one would add to a +1. So what we want is the one that adds to a positive. Now, why a +1? Because that's the middle term right here. So I want to use this number that I'm circling and this number that I'm circling. And technically that number right there is a +2. Okay. Question so far? Once you find the two numbers that multiply to the last number that add to the middle number, those are what we put inside the parentheses along with the variable. The variable here is x. How do I know it's x? Because it says x squared. So I put an x there, I put an x here, and then I write these two numbers that I just circled, -1, +2. It doesn't matter the order that you write them in. You could have written +2 first, -1 second. I'm going to claim that in blue here is the answer to this trinomial factor. Now, how could I prove that, in fact, that is the answer? Well, I could do the multiplication. I know you guys don't like to do it this way. You like the distributive property. I like the stacking one. Either one is work. FOIL method as well too would work. I like the stack. I'm just confirming that I got the right answer. 2 times -1 would be -2. 2 times x would be a +2x. All I'm doing is the standard multiplication algorithm. 2 times that, 2 times that. Bring down to 0. X times -1 would be -x, or -1x if you want to put a number. And x times x is x squared. And we can see that when we add all of these together, we do in fact get what we started with which was x squared. 2x minus x is a plus x, and -2. So I got back to what now this was just a check step, not required, but if you were ever curious, if you did it right or wrong, that you do. So there is your factoring of a trinomial. The first one we did was a factoring of a binomial. So those are the easy ones, I'll just go ahead and pick one at random to do here. I think 1 through 10 these are all the easier ones. All right, that number 5 looks like it's challenging. Let's see if it's challenging. All right, so the rule states I need to factor trinomial, not a binomial, but to factor trinomial, I need to pick two numbers that multiply to 36 that add up to +12. So how do you find those numbers? Well, it's just it's brute force. You go through every single possibility. I start with a 1. 1 times a +36, 2 times 18. Now, does 3 go into 36? It does. So 3 times what? 12. And if you're really on the ball, you're already thinking ahead about if these work or not. Does 4 go into 36? Sure. 4 times 9 is 36. Does 5? No. Does 6? Yes. 6 times 6 is 36, and we're done. There's no other numbers considered. One of these pairs adds up to 12. Well, it's pretty easy to see which one it is. It's the last one. So the last one is the only one that when you add those two numbers, you get 12. Now remember, this is a +6, and this is also a +6. Notice none of these were negative because the last answer here was positive. Now, technically, I guess all of these could be negative. A negative times a negative is a positive. But notice when we add these, we would get a negative. So I didn't need to consider any of the negative answers. Okay, so how do I write the final answer? The final answer always starts with parentheses. We starts with the variable. The variable here is n. And then I simply write these two numbers right here. So this turns into n plus 6 and n plus 6. So that wasn't too bad. This one, because this is the same thing multiplied by itself, you could have, and I'm sure this is the answer in the back, you could have written this as n times 6 twice. In other words, to the second power. Okay? So I'm sure that second way is how they wrote it. I would not mark it wrong if you wrote it in this form. All right. One more easy one, and then we'll do the more challenging ones. These are, if you remember from the class, these are our ones where the number in front of the square is 1. Remember that was the a value. And we said these were the ones where a is equal to 1. These are the easy ones. The hard ones are when a is not equal to 1. Those are 2 through 20 tonight for homework. All right, I'll pick one more to do. Let's see which one looks more challenging. Let's get something with some negatives. That's too easy. All right, this one right here, number 6. All right, number 6. Once again, I'm looking for two numbers multiplied to +32 that add up to -12. All right, so now because the middle term is negative, I already kind of know I need to consider if both terms are negative, because the only way you get to a negative on the middle through addition is if one or both of them are negative. So even though the last number is positive, so 1 times 32 is clearly 32, but that when you add those up, you're never going to get a negative. However, if they both were negative, -1 times -32, All right, that add or multiplies together and it's positive 32. And when you add them, you do in fact get a negative. So for this particular one, I'm going to consider just the negative ones. So that would be negative 2 times what? Negative 16. That would be positive 32. 3 doesn't go into 32. Does 4? Yep, 4 does. Negative 4 times what? Negative 8. That would be positive 32. Anything else? 5? No. 6? No. 7, 8. Well, that's the same thing, 8 and 4. Okay. So those are all the possibilities. And one of them, doesn't it always seem like it's the last one? One of them adds up to negative 12, the very last one. So I've already found my two numbers. Here they are. Some kids can do this whole thing in their heads. I would challenge you, just do it the long way. You're likely to make fewer mistakes doing it the way I'm showing you. Okay, what's the variable here? The variable here is x. We put an x. And then I write the two numbers, -4 and -8, and we're done. And there you go. Those are the easiest of the easiest one. I gave you 10 of those. Remember, these come in two flavors. I believe it's number 1 is flavor number 1, and the last one. Number 1, this is a binomial, what goes into both. And then number 10 or number 9, yeah, number 9, same thing. Just what can you factor out of both of those terms? The other ones are all trinomials, and you do those like with the way we just did them. Okay, so now for the ugly ones. Number 11, same way. So number 12 is the first ugly of the ugly. So this is the same general concept, but how you do it changes. So notice now what's in front of the first square is 5. So it's not 1 any longer. For instance, go back to number 10. Notice there's a 1 in front of k squared, or imaginary 1. Notice now we have a big number of 5. It's trinomial. Okay. 3 terms, trinomial. All right, so this one is a slightly different process. It's the same idea. It's going to eventually turn into parentheses, 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 parentheses. But the steps to get there have changed. Okay, so here's the process. I'll write it out. Process is that we need to multiply the first coefficient, that's that 5, times the last constant, which is -5. I need to multiply, and remember in class we said we need to multiply A times C. A was the first number, C was the last number. So if we multiply A times C, 5 times -5, we get -25. That's always, for these weird ones, that's always the first step, A times C. Second step, we're thinking of two numbers that multiply to -25 that add up to +24. Okay, so let's see. 1 times 25 is 25, but we have to have it -25. So 1 times -25 is -25. If you add those, we get -24. Well, that's close. I want it to be a +24. So if you notice, if I just flip-flop these signs, I get to my +24. -1 times +25 is -25, and together they add up to -24. So these aren't the fun. This is the difference. These aren't the final answers. These are kind of like the middle answer. Remember, this is the one where A does not equal 1. So here's what I do. I rewrite what I'm given, this whole part right here. So I got a 5n squared. And then what I do is I take the two numbers I circled. I write the first one, -1, and I attach an n to it. And then I take the second number, +25, and I attach an n to it. And then I write the very last thing, which is that -5. So all I've done, this is the process, all I've done is taking this trinomial right here and rewrote it. I rewrote it to where it now says 5n squared -1n plus 25n minus 5. In other words, see the middle? -1n plus 25 is 24n. It stays the same. All right, now why did I do that? Well, the reason why is because watch what happens. The next step, if you remember, is we do a set of parentheses. Kind of looks like the very last answer. And we factor each one of these separately. So I look at this first set of parentheses. What goes into 5n squared and 1n? The only common term they have is an n. So that's a horrible looking n. So I write an n, and I put a set of parentheses. And I factor this one by n. In other words, I'm going to divide out the letter n. What times n is 5n squared? 5n. N times 5n is 5n squared. What times n is negative 1n? Negative 1. All I did was factor out an n. I do the same thing with the second one. What goes into 25n and minus 5? A positive 5. I'm going to factor out a positive 5. What times 5 is 25n? N. Or sorry, 5n, sorry. And notice the magic here is that you're going to get exactly what you got in this first set of parentheses, 5n minus 1. What times 5 is negative 5? Negative 1. So notice by magic, and it's not by magic, if it's factorable, this will always happen. I need to erase that. That looks ugly. And let me rewrite that. 5n. Okay. So to get your, and by the way, we're done. To get to your final answer, you take what's in parentheses, and you can do it in any order, but I always take what's in parentheses, 5n minus 1, and then whatever's left, well, that's gone, and that's gone. So what's left is n plus 5. This is the ugly ones, the ones that take the most work. So my claim now is that 5n, the quantity 5n minus 1 times the quantity n plus 5 is this trinomial, and that will work. There were a couple questions on the PSAT practice where it asked you to factor one that looks like this. It was one of those really super complicated ones. It's a word problem. There's a lot of stuff to do. Maybe you might want to blow that one off. But if it's just factoring or find one of these solutions, one of these is a solution, you can certainly do this one. All right, I think I'll do about 3 of these, and you guys can do the rest for homework. So I'll just do the first couple ones in order. Let me see, are there any really ugly numbers? Ooh, that one's ugly. We'll save that one for last. All right, so let's do number 14. The only way it gets ugly is if the numbers get larger. As the numbers get larger, your number of potential factors of AC go up by a lot. All right, so it's an ugly one. Why? Because there's a number right in front of the x squared. So I need to multiply a times c. That's the first number and the last number multiplied together. So if I multiply the 3 times the negative 10, I get negative 30. Now I'm going to look for factors of negative 30 that add up to, well, there's no number there, but to positive 1. Well, clearly 1 and negative 30 multiplied together are negative 30. No way those add up to 1, so it's not that. It's probably not the 2 either. 2 times negative 15. Now, where am I putting the negative? It's your choice. I mean, it doesn't matter where I put the negative here. I'm nowhere close to 1 yet. Probably some of you already see where this is going. 3 goes into 30, so 3 times negative 10. That's not positive 1. 4 doesn't go into 30. 5 does. 5 times negative 6 is negative 30. But when you add these two, right, that would add up to negative 1. So what I really want is the 5 to be negative and the 6 to be positive. Do you see that? When you add those two, you'd get a positive 1. But when you multiply these two numbers, you get negative 30. So those are the two numbers, I'll circle them, that we want to use, not for the final answer, that's the easy ones, but to rewrite this middle term. So I'm going to rewrite that whole trinomial, 3x squared. The first number is minus 5, so minus 5x. The second number is plus 6, so plus 6x. Together, those added together would be positive 1x, so I really haven't changed anything, minus 10. All I did was take that original trinomial and rewrote the middle term as minus 5x plus 6x. Now, I got it through this process up here. All right, same process as always. We put parentheses and a parentheses and another parentheses and another parentheses, and we factor each one separately. What goes into 3x squared and 5x? Well, just an x. So I factor out an x. That's the process of saying what times x is 3x squared. Well, that would be 3x. 3x times x is 3x squared. What times x is negative 5x? Minus 5. Same thing for the second one. What can we pull out is 6x minus 10, a 2, and it's a positive 2, so we're going to pull out a plus 2. What times 2 is 6x? 3x. What times 2 is negative 10? 2 times negative 5. That's negative 10. And then we write our final answer. Our final answer is, notice in magic, this always happens. Remember, this will always happen if it's factorable. If it's not factorable, by the way, you will never get past this first step. So let's see, what's common inside the parentheses? 3x minus 5. So I took care of that. I took care of that. What's left? X plus 2. And there you go. So, and we call these the hard or the more challenging ones. Now, granted, I mean, this will take time. This isn't like, 5 seconds. Some of the easier ones, it literally is, if you have a sharp mind, you can look at the last term and the middle term and figure it out. But these take a little bit of time and practice. This is 1 to 2 minutes, certainly, to do this problem. All right, I said I would do one more. And which one? I said the one with the ugliest numbers. Let me make sure those are, in fact, that's 20. Those are big numbers. 60 is a big number. I'm just looking at A and C multiplied together. The bigger the number, the more factors. So you have more things to consider. So this one to me looks like the hardest one because the numbers are just larger. The process doesn't change, right? Since there's an A value that is not 1, then we need to do A times C. So we do A times C. A times C. 3 times 20 is 60. Big number. Big number. And 60 has lots of factors. But we got to get to a positive 19. So, 1 times 60 is 60 for sure, but that doesn't add up to positive 19. 2 times 30, that gives me a 60. That's not 19. 3 times 20, ooh, we're getting closer. That gives me a 23 added together. We're getting really close. 4 times, what is 60? 4 times 15, and there we go. And by the way, you don't need to write out all the factors. 5 and 6 both go into 60. 10 goes into 60. But we can stop as soon as we get two numbers added together that equal that middle term of 19. So positive 4 and a positive 15 both add up to positive 19. So these are how we'll rewrite that middle term. So I rewrite it 3v squared plus 4x, or sorry, v, plus 4v plus 15v. And it doesn't matter the order that you write these. And then the last one was what? Plus 20? Plus 20. Okay. Plus 20. And the cool thing is that you've already done the hard work at this point. So you just put two sets of parentheses and factor. 3v squared and 4v, the only thing they have in common is a v. So we factor out a v. Sometimes there will be another number you can factor out. In this case, no. We haven't seen one like that. So v times 3v would be v squared, 3v squared. And v times a positive 4 would be 4v. Second binomial, let's see what goes into 15 and 20. That would be a 5. And remember, we're looking for the biggest thing. So a plus 5 we can pull out. And magically, notice 5 times another 3v. Ooh, that's horrible. 5 times a 3v is 15v. And 5 times a plus 4. And sometimes, I get a little bit lazy at this point because I already know it's going to be 3v plus 4 because it factors to that. Final answer. What they share in common a 3v plus 4. And then whatever's left off. Let's see, I cross out the 3v. And you're really factoring a 3v plus 4 from both terms there. We're left with a v plus 5. If you're ever in doubt, well, obviously I'm giving you the answers today, but if you're ever in doubt, did you get the right answer? You could always multiply these two binomials together to see if you in fact get 3v squared plus 19v plus 20. All right, so I just gave you 20. I just wanted to just do a quick review of this stuff. By the way, like I said, in chapter 12, the last chapter of the book, we will do all of this again. You'll get plenty of practice at it. You get to Algebra 2. We will do this occasionally, very rarely, but occasionally in geometry. So you'll forget all this stuff. I'm doing a lot of reviewing this in my geometry class because they've forgotten how to do this. And then you get to Algebra 2, and it's like a daily occurrence that you do this stuff here in Algebra 2. For those of you going on to higher level maths, this is a very common thing, and it's like addition, subtraction, that common that becomes just a habit or something you're very comfortable doing. Certainly at the Algebra 1 level, the first year you learn this, this is Mount Everest, right, type stuff. But trust me when I say you will get better. That's kind of all I had for you. I know that this is just a quick class. I didn't want to overwhelm you on the first day. So we're in quarantine now for, whenever the the last date, was it the 21st for coming back? I didn't pay much attention. I was a little bit, I don't know if depressed or anything like that is the right word, but I was just a little bit upset that we had to do this again. But it is what it is. We'll get through it. If you have any questions on this, this is just simply a review. We will pick up 11.2. Kaylee, I know that you said that you didn't understand 11.1 and you were asked, can we do this again? I said, hey, just wait till the day before we do 11.2 and then I'll review it with you. Well, now we're on e-learning again, so we'll figure something out. We'll pick up on 11.2. So if you didn't pay much attention to this particular one, that's fine. So hopefully you understood it. But tomorrow it's a normal class. So, I'll do it live. I'll also record it. I'm going to post this probably within 30 minutes right now. That won't be a daily thing because I won't have the 30 minutes afterwards. I've got a class after this. But I will have it posted certainly before I go home by, say 4 o'clock every day. So for those of you that aren't watching this class live, then by 4 o'clock every day, the class will be posted. Try to stay on top of things. Don't be like me and get all depressed about we're back in quarantine. Stay positive. Ask questions when you need to. And then we'll get through this and we'll get back and finish the year strong. And remember, we're going to come back. We're going to take PSAT. So we're not going to do another 3 days of review for PSAT, but I might remind you of a couple things, maybe for a warm up, something like that for classes. You guys got any questions?
Can I do some review with you with these? Like just do a few for practice?
I have my audio going to someone else. Try that again, Kaylee. Question? I'm not hearing anything. All right. How about we do this instead of that? Just send me a chat and I'll answer it in chat. That'll be easier if we're having some sort of audio difficulty here. All right, that's all I had for you guys. You guys have a wonderful day, and I see you, Riley, now. So good to have you back in class. If you have any questions, Riley, or who else is here, geometry wise, I always forget is that Chris? I think has the long name. But any of the geometry kids watching this, if you have any questions, we got to get hot, heavy on that geometry, especially those that want to finish it by the end of the year. We got to get through chapter 12 and geometry 2 for you geometry kids. So make sure we got time now. So make sure you hit that one hard. All right, I'll end it here. Like I said, I'm sorry for the audio difficulty. I couldn't hear you. Send me a chat and I'll answer it in chat. I'll see you guys tomorrow.